Now, welcome to Home Class TV. I read myself Aliwi Tosin. We are taking electricity. This is part 6. Resistance in series and parallel. This is a very crucial topic in electricity, which helps in different calculations. Now, what does it mean to arrange resistance in series? This is called a series connection, where resistors are arranged side by side, one end to the other. For series connection, it is series connection, series. This series. So for series now, we say that our equivalent resistance, which is R, is given as what? R1 plus R2 plus R3 plus R4 and so on, depending on what? The number of resistors that are connected in series. Depending on resistors that are what? Connected in what? Series. So when we add this kind of connection, we call it what? Series connection. The equivalent resistor is this, which can also be referred to as the total resistance in the what? In the circuit. Now take note of this. When resistors are connected in series, there is a flow of the same amount of current through all the resistors. The currents here are what? Are the same. But while the currents are the same, the potential difference in each of these resistors are what? Different. Currents are the same in R1, R2, R3 and R4 when connected in series, but the potential difference of each of the resistors are different. Now, this is a parallel connection where we have resistors connected to their what? Terminals. Connected to their what? Terminals. You see, we are having this is a terminal here, this is a terminal here. So we are having resistors connected to their what? Terminals in a parallel connection. This parallel connection. Parallel connection. And take note, voltmeters are mostly connected in what? In parallel. We said that when we were discussing about circuits. They are connected in what? In parallel. Now, for parallel connection, our currents in R1, R2 and R3 are different. We have different currents in each, but our potential difference, that's the voltage, in R1, R2, R3 is the same. We have equal potential difference in each, but different current flowing in each. So let's take note of that. For series, the same current flowing, different potential difference. For parallel connection, the same potential difference in all the resistors, while different what? Current flowing. So for parallel connection now, we say the equivalent resistance for resistors connected in parallel now is equal to R over R1, that's R over R, so equals 1 over R is equals to R over R1 plus 1 over R2 plus 1 over R3. Now, depending on the number of what? Of resistor in the circuit. Now, some textbook can move further by just saying find the LCM of this, and we are having 1 over R. This in this, we have R1 in this, we have R2, R3, R2 in this, to remain R1, R3 times 1, that's R1, R3. By this one will be R2, R1. So we can still apply this where our equivalent resistance will now be R1, R2, R3 over R2 times R3 plus R1 times R3 plus R2 times R1. So we can say this is the formula for finding resistance in series, but when you are able to master this, I don't really think mastering this is really necessary, but sometimes we still present it this way. So when you know this, you should be able to solve for your equivalent resistor for resistors in series and resistors in parallel. Note, when cells are also arranged in series, we still have it as this same pattern 2. Cell in series, we have it as E1 plus E2 plus E3. That's when it is cells that are in the series. I'm only trying to have that, and when we are having cells arranged in parallel, it becomes E is equals to 1 over E1, 1 over E2, like that, and so on and so forth. So that is what resistance in series. Now let's take an example. Now let's take this question. Example 1. 3 resistors in 4 ohms are connected in series. Find the equivalent resistance. Solution for example 1. So far they are connected in what? In series. We say series connection is equals to R equals R1. We are told there are 3 resistors. So we have R1 plus R2 plus R3. And there are 4 ohms each. That will be 4 ohms plus 4 ohms plus 4 ohms. That gives us 12 ohms resistor. Final answer, as simple as that. That's the what? 3 different resistors in what? In series. Resistors in series. Example 2 says if 3 resistors, 2 ohms, 3 ohms, 5 ohms are connected in parallel. This means that we are using formula for parallel connection, which says how many ohms do you have there? We are having 3 resistors, so we R over R, 1 over R1 equals 1 over R equals 1 over R1 plus 1 over R2 plus 1 over R3. So 1 over R now. What's our R? Is unknown. Our R1, according to the question now, is 2 ohms. That's 1 over 2 plus our R2 is 3 ohms, 1 over 3, and our R3 is 5 ohms, 1 over what? 5. Now let's find the LCM of this. The LCM of this now should give us 30. 2 in 30 is 15. 15 times 1, 15. 3 in 30 is 3 in 30 is 10. 10 times 1, 10. 6 times 1, 6. So that means we have that should be 31. That will give us 15 plus 10 is 25 plus 6, that's 31. So you have 1 over R is equals to what? Is equals to 31 over 30. Now, with this now, normally reciprocal, this R should give us 30 over 31. But just to make it clear to us, because apply here now, we have 30. 30 is equals to 31 R divided by 31 divided by what? 31. This cancels this. Our R will become 30 over 31. Now, in decimal now, we can say that 30 over 31 will give us 0.97. 0.97 ohms. That's the equivalent resistance. Now, let's take the third one. Now, for the example 3. Now, we're having two connections here. We're having this in parallel and we're having this in what? In series. Now, what we want to do? We find the equivalent resistance of this connection in parallel first. We get a solution for it. Then we now pair it in series with other resistance. Solve this in parallel, then solve it with others in series. Now, for the parallel connection now, we say our 1 over R is equal to 1 over R1 plus 1 over R2 plus 1 over R3. So our 1 over, now our R1 is what? Is 2 ohms. R2 is 4 ohms. R3 is what? Is 3 ohms. Find LCM here. LCM here should be 12. 2 in 12 is 6. 6 times 1, 6. 3 times 1, 3. 4 times 1, 4. So we have 13 over 12. So our R1 over this is what 13 over 12. Now reciprocal of this now will give us what 12 over 13. Now 12 over 13 now will give us 0.92 ohms. Now solve it in series with this now. In series now we are having R equals R1 plus R2 plus R3. What's our R1 here? Is 2 ohms. Now our R2 now becomes the solution for this parallel series. That's 0. Okay, plus 3 ohms. So final answer here becomes what? 5.92 ohms. Final answer. So we stop there for now. That's solution. So we continue in our next episode, which is what? Electricity 7. I name myself Aliwi. Thank you.